Guys, my name is Sandip from askIITians, and today today we are going to discuss our second chapter. We in the last session we have already studied our second chapter. Right, started, that is electric current, and we can say circuit. Right. So now today we are going to find out what are the other things in that chapter. Okay. So in last session, we already talked about the different charges. That is the proton, neutron, electrons are also there. We know the masses on them. Then what are the masses, etc. Then their charges, we can say. So we already studied all those things. So normally, generally, I said we have studied the charges which are at rest. Rest means what? Static charges, right? Today, we are going to study charges in motion. Charges in motion means what? Can I say it is the electric current? Yes. We have already seen in previous session that when the charges, that is electrons normally, electron starts moving, we get the electric current. Okay. So what we are going to see today is electrical circuits. What are the different components in the electric circuits? Right. Now, consider if you want to turn on the light, right? What are the different components involved in that whole process, we can say, or in circuit, we can say. Right? Obviously, bulb must be there, bulb, or you can say tube light, right? Obviously. Then you switch on the button, right? We know that when we just switch on the button, that bulb is going to glow. Very simple. But have you even considered what is happening in that whole process when the bulb, you actually switch on the bulb, right? Actually, there is a circuit, or we can say wire, which is flowing through your button to the bulb, right? So button to the bulb, there is a wire, and obviously when you push that button, the circuit get, we can say, completed, right? Circuit gets complete, right? And then we are going to get some current, or we can say electrons flow through that, and then the bulb is going to glow. This is the simple process. But is this the only components? Think on that. I'm saying bulb, wire, and button. Are those only components? No, there must be some source, right? We also talked about the sources today, right? There must be some cell, right? But do you think cell can generate enough energy to glow the bulb, or big bulb? I'm saying, right? No, obviously we will need another source. It could be a battery, or it could be, we can say, power or energy or light we are getting from the power stations, right? So these are the general things we already know. We already daily see those things in our life, right? Okay. Now let's talk more about that. So, so this is our second session for the electricity and circuits, right? So first of all, let's see what we'll study in this. So today we are going to study about the electricity, then electric circuits. Circuits means which we already discussed. Right now that bulb is in there, then button is there, right? Button is also called as switch, right? Electric switch. Right? Then electric cell should be there. Then how we can connect the bulb to the cell, how the different combinations of the bulb, if there are, obviously in our home, you can, there is not only one bulb, right? There are many bulbs there, many instruments are there. So how to connect them into circuit, which source we should use to connect those all things, right? We have to see all these things, right, in today's session. Okay. So first of all, this diagram, we also have seen this diagram in the previous session also. Right here, what I can see, what is this positive electrode and negative electrode? Those are our cell, right? Pencil cell, dry cell, we can say. So consider this is the source. Even though there is a bulb connected to cell, obviously that cell needs to be bigger energy. It should have bigger energy, then only we can glow that bulb, right? Or if there is a very small bulb, we can say LED bulb. We can use our normal cells also. Okay. So what is electricity? Yesterday also we have seen that electricity is the rate of flow of electrons. So we know that electrons are flowing from where to where, negative to positive or positive to negative. Simple, right? Electrons do flow from negative terminal to positive terminal. So as you can see, there are different components in this cell, right? Positive electrode, negative electrode. We already know these things, right? We have seen this in the previous session. Then the electrons we can see are flowing, direction is also there, right? And there is also electrolyte, right? Electrolyte means some solution. I asked you to do some research on that. If when your cell becomes useless, try to break that cell, right, and find out what is inside that cell. So you will find something like this, that electrolyte will be there, black rod, colored rod will be there, right? Everything. Okay. So we can say we already studied about this electricity. Now let's see electric circuit. Now, this is the basic electric circuit you can see, right? So in diagrams, we can see there are very straight lines are there. We normally draw very straight lines because to see that obviously we need to show the very good diagrams. But in actual, those straight lines means what? Wires, right? Wires are like this. You can see the wires here. Right? And what we have connected here, there I can see the two bulbs, positive, negative terminals are there, right? Two bulbs are connected. Then sorry, two cells are connected, not two bulbs. These are two cells, right? Similarly, two bulbs are connected here. And what is this part? This whole part we can say this is the key. This is the button we can say, right? Normally we saw the buttons, very plastic buttons on our board. We switch that on, then we get the light. But this is the another type of button, right? We can here you can see the rubber part is there, right? So if you consider this is the rubber part, if you push that, what will happen? If you push that, this key will become something like this, right? So the circuit will break. Circuit breaks means there is no current flowing. Very simple, remember that one. If the circuit is break means circuit is open. If there is no contact, then there will be no current flowing through the circuit. So remember this part. Okay, so as we can see again, what are the different components? There must be some energy provider, we can call it as cell, or our normal light we can say, which we do get from power station. Then there must be some bulb connected, right, like this. So these are the different components of the electric circuit. Now there are many other components in the electric circuit. There is a resistance, then capacitors are there, then we have inductors. There are many concepts there, but now in the session we are not going to go into that much of detail. The simple things, basic things, that is cell, bulbs, keys. Keys means switch, we can say. Switch, button, keys are the same words for, we can say, one object, right? So this is the electric circuit. Now let's talk about electric switch, right? So what I can see here, electric switch means obviously our button, our normal button looks something like this, right? Okay. In circuit, as we have seen in the previous diagram, switch looks something like this. This is the same diagram, right? Just we are now focusing on the switch. Now, this switch, here you can see there is no contact here. If there is no contact, what I told you, if there is no contact, current is not going to flow. So what we have to do, if you want the current to flow, we have to push this key like this. What will happen if you push this key? There will be contact between these two, and now current is going to flow. Now electrons will flow from what? Negative terminal like this. This bulb will glow, we can say. Yes, this bulb is going to glow, and yes, so circuit will complete it. And remember, when we say electrons flow from negative terminal to positive terminal, now remember very carefully, we do say that current flows from positive terminal to negative terminal, right? This is different, right? Consider this. This is the positive battery. I can see the battery positive terminal also. It is positive terminal. This one is our negative terminal. Now, what I am saying that electrons are going to flow from this side like this and will come to the positive side here. Okay, so this is the direction of the current. But if you talk about the direction, sorry, this is the direction of electrons, not the current. Okay, if you talk about the current, what is going to happen? Current will flow from positive terminal like this, right? Okay, this is the convention, we can say. Normally we know who is flowing, electrons are flowing, but we are saying the current is flowing, but and also from positive direction to negative direction, right? So these are the some basic things you should know. Okay, then now as we were talking about the switch, when you are opening or closing the switch, now You can see these are the normal buttons. There are very different types of buttons. You can see even on in our home, we can say there are bigger or different types of buttons for the bigger instrument. Normally, for you could consider fridge. If you see for the fridge, that socket is bigger one, button is also bigger one, right? Why? Because refrigerator or fridge, we can say it is going to take a lot of energy. That's why. Okay. So then now let's move to the electric cell. Now yesterday also we talked about this one, right? It's previous in the previous session that primary cell and we can say secondary cell. There are different types of cells, right? So primary cell means our normal cell, right? This is one of the cell, everyday cells, right? Which we use in the clock on our walls. Okay, so again, this is the positive terminal, I know. This is our negative terminal. We can connect this cell into the circuit, then only we are going to get current. Obviously, we have to push the button, right? Button should be uh, closed there, we can say, right? So circuit will be closed. Okay. Now, in the circuit, remember, consider this is our circuit or this is our circuit. Instead of drawing directly this whole cell, right? Every time if you want to draw all the cell, that will be difficult task. So this is the symbol, I can say. This is our bulb here, right? So this is the symbol of the battery. Here you have to observe that one line is very bigger than that smaller line, right? So bigger line represents positive terminal, smaller line represents negative terminal. Very simple. Okay. So here you can see the cell, our normal cell. If you want to connect this in the battery, it will be something like this. Connect the bulb here. Again, negative, positive. Or what I can say, instead of this whole cell, I can show something like this, right? You can connect like this. Okay. So this could be the method, right? Wire, remember those wire doesn't matter how you are showing, right? Normally when we are drawing the circuits, we are going to show very neat diagram, straight line, but in actual practice they may not be like that, right? We have seen in the diagram they could be something like this. Wires could be like anything, simple. Okay, now let's talk about what is inside this cell. So here you can see the diagram, right? We have also seen this cells diagram. There was one rod inside, right? And this is, we can say, zinc casting is there. Zinc casting, we can say, right? So as I said, try to open this cell. You will find out everything which is shown in this diagram. So this outer body is called as zinc casting, and this outer body is acting as a negative terminal. Right? We know that cell has the positive as well as negative terminal. Now this outer body is going to act as negative terminal. And who is positive terminal? This rod, black colored rod you will find in that. It is actually the carbon material, carbon's rod. That carbon rod is going to act as a positive terminal, right? Then obviously insulating card covering is there. So this is the very basic thing. When you will start opening that cell, obviously this metal part will come up very easily, right? So that is actually the insulating card covering, we can say. In here you can see this is the electrolyte. We have seen in the previous diagram also there was electrolyte. So what is electrolyte? Right. So it is they are saying that it is the mixture of magnesium dioxide and graphite. Okay, it is going to give us some electrolyte there, right? Then obviously some cap is there. This cap you can see it is connected to rod. Obviously that cap is going to act as a positive terminal, right? So obviously carbon rod we can say it's our positive terminal. Okay, so now how this cell is able to provide some current there, right? If you do remember in the previous session that we have said that whenever there is a water difference, height difference, water is going to flow from higher height to lower height. Similar here, what I can say, if there is a potential difference, current is going to flow from higher potential to lower potential, right? that we have known. Now, so what is this cell is doing? Cell is actually creating the potential difference there. So a positive terminal means obviously it should have higher potential. Negative terminal means it will have lower potential. Now, is it necessary that a positive terminal means it should have positive value and negative terminal have negative value? No, right? Consider, I can say if this is our positive terminal or positive plate, let's say it has the 10 volt value, and this negative will have, let's say, 8 volt, right? So what is the difference? These are the potential, and what I'm talking about, potential difference. Potential difference means we can say that is going to decide how much energy that cell could provide. Potential difference means, can I say 10 minus 8 is equal to 2? Yes. So I can say in this case that this battery will be of 2 volt. Okay, like this. So obviously you can see both the numbers are positive here, they need not be a negative. Or you can also consider this, if there are two potentials given, let's say -4 and -6, right? Both are negative, but one of them we are supposed to say positive. Which one is positive? Remember, always the greater one is positive. Which one is the greater one here? Okay, just a minute. This is -4, -6. So -4 is greater. So obviously -4 will be our positive, -6 will be our negative terminal. Simple. Sure. So once that potential is created in the circuit, potential difference is created, that electrons are going to flow from, we know, negative terminal to positive terminal. So you just have to connect the wire here, wire in this cell, and connect one bulb here, or any resistance we can say. If you connect that, so current will start flowing. Right. I also asked you to check the potential difference on this cell. Right. I told you this is a 1.5 volt cell. This is called as the potential difference or EMF of that cell. Okay. And we already have seen the what are the internal parts of this cell. That this cell contains the carbon rod, insulating car, then we have negative terminal, positive terminal. Remember the zinc part. They do ask the question on the zinc part, right? Zinc casing means this whole electrolytes, that mixture and everything is kept on the zinc casting, right? So this is a zinc case, we can say, small, what we can say, small tin, right? And in that tin, we are going to uh, put all this electrolyte material and mixture and etc. And we are going to put the carbon rod there, brass cap, right? So it will it will create the shape, right? So now when we say negative electrons are flowing from negative terminal to positive terminal, what is actually happening, right? This negative terminal should give you some electrons, obviously, right? So can I say that already this negative terminal will have extra electrons with him compared to this carbon rod? So can I say carbon rod will have some positive charge? Yes, we can say that, right? So it is there is a deficiency of the carbon negative charge that becomes a positive charge. Why we are saying deficiency of negative charge? We know that the positive charge will not flow, right? Who is going to flow? That negative charge is going to flow. Okay, so there is a deficiency of the electrons in the carbon rod, therefore we can say it is positive and other one is negative. So whatever extra charges are there, extra charges are going to move through the circuit, this external circuit we can consider. Okay, so if they are moving in the external circuit, what is going to happen? Some electrons which are excess in this tin, we can say, right, in the cell, this is going through this wire and going towards the positive terminal. And we already know positive terminal has what? It has a deficiency of electrons. So all the electrons will accumulate there. Okay. Then now let's talk about the electrolyte. So electrolyte means there are some ions. Ions mean positive and negative ions, we can say. Ions could be positive or negative, right? So when we say positive and negative ions, they are actually transferring in that electrolyte, right? Therefore, obviously, rod and that negative terminal are going to get positive and negative terminals. Okay. So this is all about the cell and how the potential difference occurred there and how the current is going to flow. Okay. Next, let's talk about the electric cells. When we talk about the electric cells, it is called as a secondary cell. Right. These are the cell which we can say consider where we use this cell. Have you seen this cells anywhere? Right. Yes, those are in inverter. I also mentioned this cells in the previous session that if you do have the inverter in at your place, you can find out those. These are the batteries. Again, you can see there is a red terminal, black terminal. So red terminal means what? Positive battery, positive terminal. This is negative terminal, right? Very big, big we can say screw are there, right? And the wire, bigger wire is connected to this part, and which you are going to connect to inverter there, right? And this inverter again gets connected to different objects, right? In different instrument, right? Whether you are connected TV to your inverter, you can say. So even if there is a light failure, this because of this inverter, you will not feel anything, right? You can even watch the TV. So these are the secondary cells. These are also used in the different vehicles, we can say, right? So vehicles also do have the battery. So if you have four-wheeler, try to open your bonnet, right? And if you open that bonnet, you will see some battery like this, right? Why we need the battery in the car? Obviously there are some functions, right? To start, even to start the bike, start the car, we can say, right? There we need the battery there, right? And if you do remember, right, try to observe this thing that whenever you are going on suppose long trip, right, you do check the water level in that battery. Okay, so it should be able to provide the current. So again, there are now in this secondary battery there are two we can say electrodes like this, right? In the previous case, in primary case, what we said, there is only one carbon rod, and the casing is going to act as a second electrode, we can say, right? So the two terminals are there. In this bigger battery, instead of casing, there are directly we can say there are two different rods like this, right? So obviously one will be positive rod and one will be negative rod. For negative rod, we have the name cathode, and for positive rod, we can call that as anode, right? So and obviously electrons will flow from negative terminal to positive terminal like this. Okay, again this is all the electrolyte material will be there, and this Y, Z are nothing but ions, whether they could be positive ions or negative ions, you can say. Okay, next. Now, primary cell and second. Primary is the cell which is going to provide you a very less energy, obviously, right? It cannot provide you the large. You cannot even blow the bulb, bigger bulb in your room using the cell. Inverters, battery, right? This is useful for, you can say, when your light failure is there. But obviously, it will not work for a lot of time. Hardly you can say 10 hours, 12 hours, depends on the size of the battery, right? It could provide you the current or electricity. But obviously we need the light daily, right? Because of light, every instrument nowadays, we can even say that everything around us is on the light. If there is a light failure, and if you consider if you do not have the inverter, I don't think that it will be very easy light for us. Why? Because now we have become very dependent on this light. We need the light to charge the mobile. We need the light in our room. We need the light for laptops, TVs, even for our refrigerator. If there is consider if there is 2 days failure for the refrigerator, then obviously all our vegetables will go bad, right? So as we can see that our life is dependent on all this electricity. So neither that small cell is going to provide us enough energy, nor this secondary cell, right? So we are going to need a bigger source of the electricity. So bigger source means obviously whatever light we are getting from the power station, right, through our meters, right. So here in this diagram you can see this is the power plant, right. Here the lights get generated. So how actually you can generate the light, right? So again that depends, we will need some knowledge about the magnetic effect of electric current, so we are not going to go into detail of that, but just remember for time being that it has something to do with the turbines, and turbines are rotated due to, let's say, water flow, right? Or we can say even sometimes wind energy is also used, right? So what actually we are doing, there are very big coils is there, and magnets are something, magnets are there, these are very big, right? And we have to push, we have to rotate this coil. So how to rotate this coil? If this coil is very big, we need the bigger electricity, right? So we have to apply very big force on that. So who will apply the force? We obviously we cannot use the machines for that. Why? Because machines are running on the electricity, and we want to generate electricity, right? So we use there the we can say water force, right? So water turbines are there, which is actually going to rotate this coil, right? And big magnets are there, so obviously, so it is going to give us some light there, right? Electricity will get generated from here, which at this power station I can say electricity will get generated. Then it will be sent, this is transmission substation, we can say, right? So it, here they will distribute the light everywhere, right? Then high voltage transmission lines are there, right? You must have seen this very big tower somewhere, right? Normally we do not see those towers at our normal road, right, in our near to our home, but these are the very big towers because they those have very high voltage, we can say. Not those towers, but those cables which are actually carrying those, right? So those have very high voltage, so we should never even touch that, right? Okay. From this high voltage transmission light comes to power substation. Now remember one part here also, that whatever light is generated, getting generated here, it is alternating current. That is alternating current, right? So there are actually two types of current. One is alternating current, and the other is direct current, right? Let's not go into the detail right now, but remember, when the light we get from the power station, it is alternating current which is passing through this high voltage transmission lines first. Then there is a power substation, right? So from power plant, it will reach to power substation via high voltage transmission lines, we can say, right? There are transformers are there. Transformers, what are those transformers? Transformers are actually used to change the voltage of that current. Whatever current is there, you want to change. How you can change the voltage, and why you should change the voltage now? You can consider these are the very high voltage current, right? So whenever light is going to come in our home, they should not be very high voltage, because obviously high voltage line will give you some electric current, which is very bad thing, right? Obviously. And when high voltage is there, then current is less for this. Here current is less. When we say voltage is more, current will be less. So when they reaches to the power station, or we can say transformer, in transformer what we are going to do, we are going to lower its voltage, right? So when it is going to come in our home, then obviously it will have less voltage than the high voltage transmission lines. So you can use the transformer. That depends whether you have to increase the voltage or decrease the voltage, right? So there are two types of transformer, right? One is called as step up transformer, step up, and one is step down. Up means what? Increase. Simple, right? So step up means increase the voltage. Step down means decrease the voltage. Very simple to understand, right? So consider, if you want to flow this high voltage, we can convert here into step down, right? Let's reduce some voltage here. Again, after some points, we can again, if you want, you can increase the voltage there, right? And from these cables, These are now our normal pools, we can say, power pools. We can easily see, even I think outside of the window you will find something, these poles there, right? And near the home again there is one transformer, right? So whatever high voltage is flowing through this wire, this transformer drum is again going to step down, because whenever the electricity is coming in our home, inside our home, it should not have lot of voltage, right? Most probably its voltage is 220 volt voltage come inside our home, and high voltage wires means they could have the voltage of 10,000 voltage, right? Very big, right? So we cannot let that much of voltage in our home. Therefore, we use the transformer drums here, right? So this is the bigger source of electricity and the major source of electricity, where actually we are going to get energy or electricity. Simple. Sure. So now let's move to the next part. Now next we can say, so we have seen what we have seen in this session. First of all, we have seen different parts of the circuit. Those are buttons, bulbs, then we have the batteries. We have studied something about the buttons. Push up button, we can say, right? Push up button means what? We have to push that button, then you can get the electricity. The circuit will close. If the button is open, open means what? In our normal terms, we can say button is off. Off means, remember, there is some irony there. We can say some opposite terms are there. When we say off, turn off the button. Turn off the button means in circuit actually it opens like this. It gets opens. So circuit is open. So when we turn off the button, we are going to say circuit is open. Turn off means circuit is open. Very simple to understand, right? Then if you turn on the button, turn on the switch, we are going to say it is a closed circuit. Closed circuit means this button will look something like this, right? Turn on the switch means circuit is closed. Remember this one. These two looks opposite, because off means open and on means close. Okay, so this is about the button. Then we also studied about the cells. There are different types of cells. Either it could be primary cell or secondary cell, we can say, right? And in primary cell means our smaller cell which cannot provide us a lot of energy. But we also have seen the secondary cell. In primary cell, what is important? That zinc casing, as I said, zinc casing is important, right? They could ask you the question about which casing is there. Then electrolyte is there. Then one carbon rod is there. Carbon rod is acting at what? As what? It is acting as positive terminal, and that casing is acting as negative terminal, right? Then we also talked about the secondary cell. Secondary cell means where we can see those cells. Secondary cells mean inverter batteries, right? Bigger batteries, which are bigger obviously than our batteries. Those could be used in our cars, we can say, right? Four-wheelers, even two-wheelers have some very small battery. That's not as big as four-wheeler or our inverter battery, but it has smaller battery obviously, right? Normally you can say horn of the bike or car. It's dependent on that battery. If the battery is down, you will not able to uh, sound the horn, we can say. Then we also have seen that bigger source means what? That electricity which is coming from power stations, right? That is actually a very big process. The whole electricity is coming through a lot of cables to our home, right? As we also said that it is a high voltage current, we have to reduce it to the lower voltage. Which instrument we see there? That was transformer there, right? Now let's move to the next point. Next element of the circuit is electric bulb. Normally we can consider any other instrument also. But now let's talk about the bulb. So this is the normal basic bulb. Nowadays we get a CFL bulb. CFL bulb means white color bulb. They produce a white current. But initially this type of bulbs used to come there, right? They used to give you yellow current instead of white current. Right? Now this bulb shows the, obviously there could be different colors also, blue, red, like that. But one bulb actually can produce, normally generally it produces only one color. So either it will produce blue or green or red. Normal bulbs used to produce the yellow current there, right? So when we connect the bulb in the circuit, obviously, as I said, we will need bigger battery, right, to glow this bulb. This small battery which we use in our remote or clock is not going to be very useful in this case, right? So we will need bigger battery there, and when we push the switch, this is the bulb, this is the key, right? Key or switch or button, we can say, right? If you push the button now, here you cannot see any connection there. You just have to on or off the button, similar to our buttons at home, right? Buttons on our wall, we can say. So you can do the same thing here. And battery is connected like this, and the current is going to flow. Simple. So bulb will glow. Now, how this bulb is glowing and what are the elements in that bulb? Right? Now here you can see there is some metal part here. This is the metal part, I can say, and inside that bulb is the some you can see this is the wire, right? You can see such kind of wire here. Also you can see that wire. This is something like this wire, right? This wire is very important, right? So question do appear like this, right? Which wire will be used in that bulb, right? So remember one name, tungsten. Its name is tungsten. So we use the tungsten wire inside that bulb, which actually have very high melting point. High melting point means what? If the lot of current is going inside that tungsten wire, this coil, we can say that coil is not going to melt down. Obviously, it should be able to take the lot of current, because what actually it has to do, it has to glow and produce some light there, right? And obviously there is a glass covering is there that is transmitting the light to all over the room, we can say. So this is about the bulb. Okay. Now next one is electric torch, right? So nowadays we don't use the torch, we have the mobile, right? And mobile have the batteries. So normally we don't use the torch nowadays, but in the old times again, there used to be this type of battery, right? Now, as we already know that the small bulbs, small cells are there. Instead of that, this battery used to have a bigger cells. So consider this is our smaller cell. So this bigger cell will have size something like this. Obviously, it will generate the more potential, and not only one, but that battery, that torch needed two different cells like this, right? Bulb is also connected there, right? So, and this is the switch, we can say. Right? Now here, this switch is a slide switch. Slide switch means we have to push this button forward, right? Like this. We nowadays in our mobile also we have sometimes there is a small button, sliding button. We just push that button upward. Similar to that, this battery or torch, I can say, also used to have the sliding button, and if you push that button, the circuit will get connected, uh, and obviously current will flow and the bulb will glow. Bulb glow means we can say torch will glow, right? If we close that button, so let's slide this button here. This here you can see closely. If you look here, there is a connection here. Right? If you turn on the button, slide the button downward, this connection will go away, right? So circuit will break, I can say. So it can become open circuit. Once the circuit becomes open, current will not flow, bulb will not glow. So we can say that we turn on the battery or torch. Okay. So again, this was the glass part, you can say, and they used to have some mirrors type here, something like mirror, right? Not exactly the mirror, but silvering, we can say, right? So it will give you the effect of mirror. So more and more light will go outside, right? That's what is used to happen in this electrical torch, right? So what we have, that's what they have told here. Reflector means obviously we have to use some mirror part there. Then electric cells are there, which are actually going to provide you some energy, right? Obviously, we don't need the light for those because so we have connected the electrical cells there. Slider means button is there. Plastic casing is there. Why we are using the plastic casing? Why not the metal casing? Right? Because plastic is insulator. Obviously, you are going to hold this torch in your hand. So current, you should not get the shock because of this current. So plastic is acting as a insulator, we can say. So it is safe for us. Right? So this is about the electric torch, I can say, right? Now let's move to the next one. Now let's talk about little bit about the resistor. Okay. So those are very small element. Resistor are very small elements. So there you can find those elements, right? For that now I have told you the cell becomes useless. Break the cell and study whatever is inside. Similarly, if there is a remote control car, right? Consider if there is a remote control car which uses the cells, right? If that becomes useless, right? Try to break that too. Right? You will see lot of electrical elements inside of those, right? And these resistances will also be there, right? So now when we say resistances, what is resistance? Resistance is nothing but, as the name suggests, can I say it is resisting something, right? Resistance means it is going to resist something. Resist what it is going to resist. If you connected this part in the, let's say with the battery in the series here or something like that, battery is connected 10 volt. You can see here, I have told you about the symbol, right? Positive and negative terminal. Now instead of only one positive and negative line, if you want to say that it is a bigger battery, connect more like this. So it will show you the bigger battery. So they have connected the two here. So let's say it is a 10 volt. Right? It is not like that when if you connected two positive terminal, two negative, two pairs we can say, then it is a 10 volt. One pair means 5 volt. No, not like that. You can just say it is a bigger battery. You have to use the more number of lines, right? Of positive as well as negative terminals. Okay. Now, when we connect the battery, obviously what we know, if the battery is there, it is going, some current is going to flow through that battery, right? And we also have some resistance there, that is 5 ohm resistance, I can see there, right? So resistance, as the word suggests, as the name suggests, it is going to resist. What it is going to resist? What battery is providing? Battery is providing current. So resistance job is to resist that current. Simple. Now, this resistance has the unit of ohm. You can see this small symbol is there, which is called as ohm. So this electrical resistance, which are very small in size, very small. You can say this only this much of part is there, or very small sizes. And we can connect across those our normal wires, right? And now those are going to give you the, or they are going to stop the current. We can say. Okay? So if these are the resistances, you can see different colors are there of, these are blue colored resistance, we can say. Even on that blue color, there are 4 different marking are there. Actually this is there is also silver marking. It is not visible here, but you can see closely, there is also a silver marking on this, right? And this brown color resistance, again you can see there are 4 different colors are marked there. Obviously they must represent something. Yes, so these markings actually represent the value of that resistance. So when we say 5 ohm, if I want to connect 5 ohm resistance, so this marking should will give me which one will be the 5 ohm resistance. So I have to take that resistance and connect those. Right? If you want to change the value, let's say 10 ohm resistance, right? This marking is going to denote which resistance is 10 ohm. Accordingly, we can select that resistance. Okay. Then now let's talk about the resistances in series. So we already seen that if the battery is connected, battery can be represented like this. Now resistance R1, R2 and R3 are connected in series means what? just connect them into the single wire, we can say like this, right? So what you can do, consider this our battery, take one wire like this, right? Here connect one resistance, that small resistance, right? Depending on how much value we should take, need. Connect another one here, connect one more here. So this is, we can call this as a resistors in series. Now, one formula we need to know here, which is given by a scientist named Ohm. Scientist name is Ohm. He gave us one formula, which is the relation, we can say relation between potential or potential difference, I can say, right? 10 volt battery, 20 volt battery, etc. Right? Then current, how much current is going to flow. Current flows means what flows? Charges flow. Charges means which charges? Positive or negative? Negative charges, that is electrons flow. From where to where? Negative terminal to positive terminal. So can I say electrons are flowing like this? Yes, that's right. How the current we should represent? Current should be opposite in direction of flow of electrons. So I can say electrons are flowing like this. So from every resistance, we can say same current is flowing. Again, same current is flowing through every resistance. So as we were talking about the Ohm, V, that is potential difference, I, and the third part is resistance. So what Ohm said actually, Ohm said that V is equal to IR. This is the formula he gave us. Very simple formula. V is potential, I is current, and R is resistance. So let's try to solve one simple example. Consider this is 10 volt battery. Resistance is given, let's say 5 ohm, right? Can you tell me what will be the value of current from this two? Right, think on that for 1 minute and find out how much will be the current value there. Right, we have the formula given by Ohm. Right, Ohm said V is equal to IR. So let's try to substitute the values. V is how much? Let's say given I can say V is equal to 10 volt. R is given as 5 ohm, and current, let's substitute these values. Current we need to find. So can I say V means 10 is equal to current into 5. If you do the calculations, you will get the answer as 2. And anybody remember the unit of current? That's right, it is ampere, right? So very simple question, very simple formula Ohm gave us. Ohm is the name of scientist. So we know that name of scientists are given to the units. So for resistance, his name is given, right? And Ohm, this is represented by this symbol, Ohm, like this. Okay, we have seen this. So now, when we connect now here is only one resistance. We got the answer 5. We just divided it. It's very easy. Now what happens if this 1, 2, 3 resistances I can see which are connected in series there, right? What to do? So remember, there are two types actually, resistances in series, and let's say this is the second type. This is a resistance in parallel. So remember, whenever resistances are series, there is same current is going to flow through this. So important point you should remember, that same current flows through the resistor in series. And when we talk about the potential, this potential get divided into different parts. Now remember this very carefully. If this is R1, this is V1. V1 means potential across two different points of the two starting and end point, I can say. Start and end point of resistance R1. Similarly, I can say this is V2. Potential difference between start and end point of R2. This is V3. Right? Like this I can show. So in series, same current is there, but different potential. These two important words you should remember in this case. What I'm saying, same current but different potential, right? And V1 plus V2 plus V3, if I add all these potentials, I'm going to get the main battery's potential. Remember that part too. Okay, so what I can say here, simple, V is equal to V1 plus V2 plus V3. Who is going to remain same? Current. Who is going to change? Potential. Simple. Now let's see the formula for V. Is IR, right? IR is my basic formula. And for V1, V1 is the potential difference, I can say, across R1. So should I say this I1 R1? Right? But I is not I1 because I is same everywhere. So I don't say I1. Instead of that, I can just write I1 R1. Similarly, for V2, what I can say for V2, can I say I2 R2? I don't need I2, right? Because current is same. Similarly, for V3, what I can say? I R3. Simple. Now, let's do one thing. Let's take this I common and let's call this as R equivalent. Equivalent means what? If instead of these three different resistors, if I have connected, let's say, I have to replace that three resistance with only one resistance, what should be the value? That's what we are actually calculating here. So R1 plus R2 plus R3. So this becomes I into R equivalent. Can I say I and I will get cancelled? So R equivalent will be R1 plus R2 plus R3. So remember very carefully, when we say resistances are connected in series, there should be same current but different potential. So the potential is different. So I am going to say V is equal to V1 plus V2 plus V3. And using all this, I'm going to get one very simple formula. So formula says just add all those things, so you'll get the equivalent resistance. Now, how to use this in question? Now consider this part. We have already solved one question like this. Now let's try to solve this one. This is the 10-volt battery is there. 5 ohm, 5 ohm, 5 ohm. What we have done here now, connected three resistances. Now I have to change this circuit. Now we can consider, instead of these three resistances, I am going to let's assume that we are going to remove these three resistances and connect only one resistance here. What should be the value of that resistance? Formula is going to give us. Which is the formula? R equivalent is equal to R1 plus R2 plus R3. So 5 plus 5 plus 5, how much? That will be 15, right? So what I'm getting now, instead of connecting three resistances of 5, 5, 5, I'm going to connect just one resistance of 15 ohm. This is 10 volt. So using this, I can again use this formula and 10 ohm similar to this. What was our formula? Here V is equal to IR, right? So V again I can say V is equal to IR. So 10 is equal to I don't know. This is 15. So I can say I is equal to 10 by 15 or 2 by 3, right? 2 by 3 ampere. So we can say here current we got as 2 by 3 ampere. It is in series, I can say potential is getting divided, but current is same. This is how we can calculate. It is not necessary that this should have the same values of resistances, that is 5, 5, 5 ohm, right? Let's take another example. Consider there are, or it's also not necessary that it should have three resistances. It could only have 2 or 4 or 10 or 100, doesn't matter, right? Whatever resistances are connected in series, let's say 2 and 6, two resistances are there, right? 10-volt battery is there. What I can say, just replace this this circuit. So it will look now something like this. 8 ohm battery will be 10 volt. And now you can calculate the current using the same method. Okay. So this is how we can see the resistances in series. Now let's talk about the resistances in parallel. This is how we can connect, right? In consider our normal diagram. If this is the cell, right? What we are going to do? Normally we connect battery like this, right? So what we are going to do here, if you remember in series, there was only one wire. We connected the three resistances there. Now for this part, we are going to connect one more wire like this, right? And let's connect another resistance here in between. So this is second resistance. Let's connect one more another wire here. and this is our third resistance, right? So this is actual diagram, but obviously we know we draw the very neat diagram, straight lines, straight wires are there. So diagram will look something like this, right? Now when we say parallel, remember, whenever we are going to say parallel, you have to say same potential, different current. Same potential and different current. So what is the meaning of that? The potential between, let's say, R1. In the previous case, we have said that potential is different. Now here the potential between these 2 points will be same. For this 2 point, it will be same. That is V. It is not going to change. Here it is also V. Right? So every resistance is not going to now going to have the same change. Who is changing? Current is changing. Right? So how the current is going from positive terminal to negative terminal, I know that part. So I will be going like this. And here at this point, it is getting distributed. Like what? I1 will go here, I2 will go here, I3 will go here. So I1 again, it will come here. At this point, I1 is coming. You can say I2 is also coming. I3 is also coming at this point. Same point. So again, all the I1, I2, I3 are getting collected, and I can say total current will be I. Again, will flow towards the negative end of the battery. Right. So using this diagram, tell me, can I say I is equal to I1 plus I2 plus I3? Right, simple. I is equal to I1 plus I2 plus I3. Now again we are going to use the Ohm's law. What is our Ohm's law says? Ohm's law says that V is equal to IR. Can I say I is equal to V upon R? That's right. Now V is going to be same everywhere, right? We have said here same potential. So for I can say V upon R. For I1, I have to say V1 upon R1, right? No, there is some mistake. V1, no, there is no V1. There is only V because potential is same. Similarly, there is no V2, right? There is no V3. So this is the formula I got. Again, can I say V? Let's take V common. So 1 upon R1 plus 1 upon R2 plus 1 upon R3. Simple. And V upon R. Again, we will get cancelled. Let's say this is R equivalent. R equivalent means what? Instead of 3 resistance, just remove those 3 resistance from the circuit and just connect this one resistance. Whatever is the value, we can calculate by using this formula. Which formula? We got the formula here. 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Right? In the series, what we said, just add all those. But here, this formula is a little bit of different. Right? Let's try to solve one question on that. Right? Consider we connect the 3 resistances, 6 ohm, like this. Let me draw one diagram here. So let's say this is 6 ohm resistance. Another is also 6 ohm resistance here, and 6 ohm resistances, right? We can see those are in parallel. Let's connect all these to, let's say, 30 volt battery, and we want to calculate current. What we are going to do? First of all, replace this diagram by only one small equivalent like this, or equivalent resistance. How to calculate equivalent resistance? Use this formula. Let's try to calculate this. So 1 upon equivalent is equal to 1 by 6 plus 1 by 6 plus 1 by 6. If the denominator is same, what we can do? We can simply just add all this, right? So 3 by 6 will become 1 by 2. So remember, 1 upon R equivalent is 1 by 2. What we want to calculate? Actually R equivalent. So we have to take the inverse of that 1/2, that is 2 ohm. Right? So what I can see in this case, R equivalent becomes 2 ohm. This is our 30 volt battery, and using our normal formula, I is equal to V upon R, I can calculate the current, that is 30 upon 2 is equal to 15 ampere. Okay. This is how the resistances in parallel do work. Okay. Sure. So in series parallel, we should know. Now, let's see some questions which are normally appear in our exams. So first question says state whether it is true or false, right? So first this says the effective resistance is series combination is higher than single resistance. Let's check this out, right? In the previous slide, We have taken, consider this example. 5, 5, 5, we connected in series. What is the total resistance? 15 ohm. Is it greater than each resistance? Yes. Consider the second example also. 2 and 6. What is the total resistance? 8. Is it greater than the two resistances? Yes. Right. So can I say this is true? That's right. Then, when the electric circuit is open, electric current flows through it. Is this right or wrong? You know, if the button is off, off means switch is open or circuit is open. Remember this thing, right? If the circuit is open, bulb will not go glow. If the bulb is not glowing, we can say current will not flow. Then electric current is the rate of flow of charge. Yes, this is our definition. Remember this definition. Very important definition, right? Electric current is a rate of flow of charge. That is true. Then how can we divide voltage using resistances? How to divide voltage, right? In the series combination, we have seen that voltage gets divided, current remains same. I said that 2 points are very important for us for series. Voltage is different, current is same. And voltage is getting divided means V1 plus V2 plus V3 is equal to V. Right? Simple. So we have to connect the resistances in series. So what I can write the answer, connect the resistances in series, so voltage will get divided. Then if 3 ohm resistance is connected in a circuit across 3-volt battery, how much current will flow? Very simple, right? Now only one resistance is there, one battery is there. We already know the formula. What is the formula? V is equal to I R, or I can also say this is nothing but I is equal to V by R. Right? Try to substitute the values and tell me the answer. Right? That will be how much? 3 upon 3 is equal to 1 ampere. Very simple, right? Okay. Then this question says MCQs are given there. Electrical cell converts light energy into chemical energy. Now, electrical cell, obviously, what we are getting from the electric cell when we use that small cell or secondary cell, what we are getting? We are getting the current. Current means what? Electrical, something electrical, obviously, right? So what we are getting? Electrical energy. So let's read the first option. Light energy into chemical energy. No, we are not getting chemical energy. We are getting electrical. So this is wrong. Chemical energy into light energy. We are not getting light energy either. So this is also wrong. Chemical energy into electrical energy. Yes, we are getting the electrical energy. Right? And electrical energy into chemical energy. We are not getting chemical energy. So obviously there is only one option who says the electric, we are getting the electrical energy, right? But who is converting it? When we talked about the cell, there are electrolyte, I said, right? So that electrolyte means what? There is chemical things there, right? So energy in that compound will be chemical energy. So I can see here chemical energy is getting converted into electrical energy. Okay. Let's move to the next question. If 3 resistances of 12 ohm each are connected in parallel, the equivalent resistance will be, right? Parallel means we have seen this diagram, right? So this is our one diagram for the parallel, and it is connected to battery. They haven't mentioned how much voltage is the battery. We don't care about that. They are just asking us the equivalent resistance. So let's substitute the values here. This is each resistance is how much? 12 ohm, 12 ohm, 12 ohm, and we want to calculate the R equivalent. Now we know in series what we do, we just directly add all those numbers. So 12 plus 12 plus 12 will become 36. But have they said series? No, in parallel. So can I say this 36 is the wrong option? Right? Very easy. In parallel, what is the formula for parallel? Remember, it is 1 upon R equivalent. 1 upon R equivalent means what? We again have to take the inverse final when we got the final answer. Let's try to solve this. So 1 upon R1 plus 1 upon R2 plus 1 upon R3. So can I say this is 1 by 12 plus 1 by 12 plus 1 by 12? As the denominator is same, add the all numbers in the numerator. that will be 3 by 4 or 1 by 4. So R equivalent is 1 by 4. Is my answer 1 by 4? No. R equivalent means it is inverse. I can see, so I have to inverse that. So R equivalent becomes what? Inverse of 1 by 4 is how much? 4. So let's say answer is 4 ohm. Right. So this is how we can calculate the resistances in parallel. Next, filament. It should be filament, right? I should be in between there. Filament of electric bulb is made up of. I told you this word is very important, right? It is made up of tungsten. Why tungsten? Because tungsten have very high melting point. It does not easily melt, right? So it will require a lot of temperature to melt, right? So obviously current is passing, it is producing some heat, light, so it should not melt. Therefore, we are going to use the tungsten there, right? So these are some questions from this chapter. So we have covered the second session of this chapter, that is electric and circuit. Today we have studied, yesterday we have studied about the charges, static charges, what are electrons, protons, neutrons, right? And today what we studied the different components of the electrical circuits. Those are buttons, switches we can say, or keys we can say, right? Then we'll studied about the bulb, right? How the bulb work. Then cell are there. Primary cell, it could be primary, secondary, and which one is the bigger cell, bigger source of the light? That is our electricity we are getting from the power station, right? And then we also studied about the torch, how the torch will work. It will also require some batteries there, right? It cannot work on the electricity. Normally, why we use the torch, right? When there is a failure of electricity, we are going to use the torch. Or outside, when we go outside, we are going to use torch, right? Nowadays we do not even use the torch, we use our mobile's battery. Very easy, right? Very convenient. Then we also talked about the resistances. What is resistance? Then Ohm's law is also important. One formula is there, we use that one, right? Then what happens if you connect the resistances in series, resistances in parallel, like that, right? So one thing, study this chapter very carefully, and if you do have any questions, please put your questions on forum, so I will be able to solve those for you, right? And your query will get clear. Okay, sure. So today we'll stop here. In next session, what we are going to do? In next section, we are going to study about the conductors, insulators, etc. Why we use the conductors and insulator, what are those? And also we will study the bulbs which are connected in series or parallel, what will happen in that case. We'll study about that, right? So today we'll stop here anyway. So thank you very much. Have a nice day.